Hello guys, in this video I am going to explain the solution of this question number 11 from chapter 11 from the books Circuit Engineering Circuit Analysis by Hayt, Kemmerly and Derwin. So the question says that the phasor current is given, which is in milliampere, and it is corresponding to the sinusoidal operating at 45 radian per second, and this is applied to a series combination of 18K resistor and a 1 microfarad capacitor. We need to determine the expression for the instantaneous power, and we need to determine the average power absorbed by the combined load. So it means, let us draw the circuit. So over here it is given that we have a resistor, we have a capacitor connected in series with a current source, and the current source it is given as this 18K, and this is 1 microfarad, right? And it is omega it is given as 45 radian per second. Now to solve this circuit, first of all, what we can do, we can use the concept of impedance. So as per the concept of impedance, this capacitor, it can be replaced, like C can be replaced with minus j upon omega C, right? So minus j upon omega is 45 into C. C is 1 microfarad, means 10 power minus 6, right? And this will be evaluated as minus 22.22 J kilo ohms, right? So it means we can write that it is equivalent to minus 22.22 J kilo ohms. Now with this circuit, the total impedance is 18 minus 22.22 J kilo ohms, right? And this can be converted into the polar form as minus 51 degree, right? So we know the current is our I equals to this, so we can determine our V as I into Z. So I is 9 angle 15, Z is 28.6 angle 51 minus 51 degree. So we get the voltage as 257 angle this 15 minus 51. So 15 minus 51, so we get 257 angle is minus 36 degrees. So this is our voltage, right? Now this voltage can be written in time domain form as 25. This is 0.4 also is there, right? So 257.4 cos omega t minus 36. And similarly, current can be written as, current is given as this is current, right? So it can be written as 9 cos omega t plus 15. Now when we talk about the instantaneous, this is time domain in time varying. So our instantaneous power, it can be expressed using the formula this, right? This is I current. Substituting these values, we get 257.4 cos omega. Now omega, it is given that omega is 45, right? So substituting this value also, so we will get, it will be cos 45 minus 46, right? Now for the I into 9 cos 45, it is t also is there, t minus 45 t plus 15. So solving this, we will get 2316.6 cos 45t minus 36 cos 45t plus 15, and applying the trigonometry we can get this cos this 2 into 45t minus 21 plus cos 51. How we get this formula? We know one formula, that 2 cos a cos b, it is equals to cos a plus b plus cos a minus b. So just using this formula on this, we get this, right? So this is our instantaneous expression for the instantaneous power. Instantaneous power. Right, now the second part, which is the first part of the question, this instantaneous power. Now the second part of the question says that we need to determine the average power absorbed by the combined load. Means we need to determine the absorbed power for this corresponding to this instantaneous power. So we know that average power for this PT. Now this is a sinusoidal. That means the graph for this, it will be something like this, right? And since this sine waves, if they are repeating, so this minus and this plus, they will cancel out each other. So the average power for this case, for this, it will be 0. So it means overall average power will be contributed only by this factor, and the average power for this term, it is expressed as a half of Vm into Im. So this expression, so usually, like if we know that if our expression is something like this, Vm Im cos 2 omega t plus theta plus cos theta 1. So for this case, for this instantaneous power, average power, it is expressed as half Vm Im cos theta 1, right? So over here the average power, it will be expressed as, for this case, it will be average power will be half. Now Vm and Im, it is this Vm and Im, right? So the product of this, so it is 257.4 into 9 cos theta 1. Cos theta 1 is this, right? 51 cos 51. So solving this, we will get the answer something as 728.94 milliwatt. So this is the average power, right? So simply, or if you are confused how I write this, so simply, since we already solved like this particular expression 1158.3, it is simply Vm Im upon 2, right? So you can simply use this 1158. This will evaluate to 1158.3. So this is 1158.3, right? And into cos 51 you will get this. So this is the answer solution to the question number 11 of this book. So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.